So just to begin, I am Maria-Stella Nikolaou. I'm a PhD student in the University of Athens from Educational Technology Lab. And Marianthi Grizioti, who is also here, she's an assistant professor in our department. But both of us have a background in informatics, so it's kind of weird. So I will present you our work regarding playing, moving, and designing with data, and exploring young students' data literacy skills in embodied classification games. To begin with, data literacy, I don't know if you're familiar with the term, is increasingly recognized as a key competence for everybody in the AI era nowadays. So it's not only about using data, but about being able to question and understand how data are classified and represented. Yet, in K-12 education, we see a lack of motivating and accessible designs to introduce students to data literacy, because too often it's reduced to more statistical or isolated exercises that don't feel meaningful for learners. So our goal is to design and evaluate purposefully an educational game which integrates multimodal interaction and end-user development as well for data classification. And you probably wonder why we choose classification. The answer is because it's everywhere. It is in science, in how algorithms work, in everyday life. So classification is not something that you learn once and finish. It keeps evolving as new data and perspectives come in. So we will present you sorbet. As for sorting based on educational technology, it's not an ice cream, unfortunately. It is an online tool for classification games we develop in our lab. It is open source and web-based, so it's really open for everybody to use and really lightweight. It is also, as I said, editable, so you probably want to play classification games or design your own. So we have two levels of user engagement, the play and the modify design phase. In the play, we classify the following objects with also integrated hand tracking system to allow multiple users to play. Currently just two, but we plan on elaborating more. And also voice recognition commands to make it more engaging through gameplay. And also the modify and design phase where we have integrated block-based programming and the data editing parameters. So we have a more intuitive and physical engagement at the first level, and then a deeper engagement with the data handling. It's really open to any domain, so you're welcome to come up with any ideas and share with us. So this is the interface. It's really simple. Now in this video, I will just select the one example to showcase to you. It's a recorded video because I was afraid that something will go wrong if I do it online. So this is a game about the gradation time, so the time of everyday objects, so that objects are falling, objects are everyday objects like tires or whatever, and the categories are the amount of time estimated to need for dissolve. So a bit about the interface, it's really simple. You can set on or off the background for visual clarity. The camera should be on. It's important to say that there is no further equipment needed. It's just a standard web camera. That's why I said it's really easy to use. And so objects are falling. We have two hand gestures that can manipulate these objects. The objects are falling in waves. So during gameplay, maybe the students that are playing may be frustrated because of the objects that are too many or they fall too fast. So with some keywords like slower or less, the design can adjust to what the student need. So yes, just move on a bit faster. Here is the edit mode. As you can see, it's really easy to move from play to edit. It's just a button. And here is the database where you can see all the objects and categories that we saw earlier. We can add more categories. We can delete existing ones. The objects are in the rows. They can be either text or image. And also we can select how many times we want an object to appear during gameplay, because sometimes we want an object to appear more than once in order to make students reflect on that. So it goes a little bit too fast. And also the object can be assigned to more than one category so as to make students reflect on the subjectivity of classification. So also we have this playground with block-based commands here that let students experiment with the ratio and the pace of the objects based on some criteria, maybe the score of the game. And also a text editor that allows students to write their own text for introducing their games. Another example, as you can see here, we have these online examples drop-down menu where we have plenty of examples, and of course we are adding more and more during time. I will open a different example. It's called App Game. We talked about social interaction before, but we have now very popular social media, and this was a really subjective theme, as you can imagine, because they were tasked to classify apps based on their use. So it's really open and subjective on purpose, just to let students to express their own view on these things. So we have many different examples regarding that. But let's move to more theoretical background that led us here. Our work has been built in 3 complementary perspectives that guided the design of Sorbet. So we start with data literacy, which is about questioning how data is organized, classified, and used. From an HCI perspective, the embodied and multimodal interaction, like gestures and voice, make abstract concepts more tangible, social, and of course negotiable. That's the most important thing part, I think. And they also change how students collaborate. And finally, constructionism, where students learn best when they design and share the artifacts. And by letting them redesign these classification games, we place them not only as players, but also as makers of the systems. So regarding this study, I have to say that's a pilot small-scale study, a part of my PhD journey. And the methodology followed a design-based research. So it is an iterative process and user-centered, which works in cycles. So the first cycle had an earlier version of Sorbet. So back then it was only one gesture detected with a different interaction. It was like open palm, closed fist interaction that grab the objects and move them around. And the more simple design mode with just the database and not anything else. So the students worked in pairs. It was really small sample. And in the second cycle, based on students' feedback from the first one and student interview mainly, there was a strong need for dual hand interaction at the same time to be more engaged and collaborating for them, and also additional affordances in the game design. So we added these options in the design mode. Yes, so as I said, we have done 2 cycles so far, 2 pilot studies. It's an ongoing research. In both interventions, students moved from play to edit the games and finally to create their own versions and share with classmates, which was the most important part because they started to feel them more like it's something that it's theirs. In both interventions, the data analysis, the data collection included gameplay observations and logs, discussion interviews, and student-created artifacts. So as you can see in the first images, in the first intervention, the students were sitting down, there was less engaged, only one hand can be detected during that time. But in the second intervention, they were more active, more talkative, and there was stronger collaboration between the two. They were standing up and moving around, yelling. So some findings, initial findings regarding Sorbet affordance's connection to data literacy practices show that multiple ways and practices are interconnected. For example, embodied gameplay and database editing led students to reflect on the subjectivity of categories, which was really important. And some findings regarding embodiment in focus, we saw that with embodied and voice interaction, the students moved from just playing to questioning the classifications themselves. And the dual hand supported strongly collaboration and equal participation, which of course aided expression of meanings while voice commands layered in a sense of real-time strategy and negotiation between the two players. Also, when given access to the database and the block-based environment, they moved from playful edits to more purposeful design choices. So they created new categories with evidence they search online, and it was a critical step toward more ethical and communicative data literacy, because it marked a shift from designing for themselves to designing from others. Okay, I will skip these examples that mostly illustrate how Sorbet provoked students to treat classification not as a fixed truth, but as a negotiable and contestable process, which is valuable for technologies like this, which is authorizable and easy for access. So just for discussion, we try to reframe data literacy as an active social and design practice, and we focus on enhancing the critical view of data and expression of ideas. Of course, we acknowledge the limited sample size currently, and we intend to have larger populations, and of course, improve the usability and the design options of the platform. And also just to assign about the curriculum alignment, it's really important for students nowadays, and maybe integrate it in out-of-school settings like museums and classifying data regarding their visit there, which is an idea for the future. Thank you. I hope I'm not really in time.
Maria-Stella, thank you for the talk. Very nice, and I like the setup, the presentation, the videos. I just have some, I'm curious a bit on the framing of this research. Now, you talk about data literacy. Data literacy, which is different than digital literacy, has to do with the way this age group perceives data, sees how data is transformed, is manipulated, is stored, and issues relating perhaps to privacy and other issues relating to data. Now, I was really confused about this gesture, embodied interaction with data. I see really, I can't see how this can contribute to data literacy. It adds a playful character in the interaction, and then perhaps based on the ability of the kids to manipulate these falling objects, makes them focus more on catching the objects and handling them, rather than on the mental process of categorizing all those concepts. And another point is that, where is the data there? I mean, for them, data becomes what? Objects which represent notions. This is more an activity on ecology, on I think it's the life of various. I couldn't understand exactly the domain.
Yeah, it was just an example about degradation of the objects. We have plenty of examples.
Because at the bottom, the categories related to a time scale. How long? It
was just for this example. It's not.
Yeah, okay. But I mean, the data seem to be missing there. The representations of data. Perhaps more interesting for these kids would be to look into the database later, or perhaps even, which I agree, it's an interesting example, to create through this Scratch environment some kind of processes for managing and manipulating data. That I think is much more interesting. It would be interesting to discuss that. But the game itself and the way, it's far too distant from the notions that we want to achieve with data literacy. And I really don't say, I think it creates more, it's not, it doesn't give a clear message why you're doing it.
Thank you for that. I don't know if you're finished.
I don't know whether I would like your reflection on this. It's a very interesting work, and I would like to see methodologically how you're going to evaluate your work. I mean, what is the criteria for achieving the objective, which is data literacy, I guess. And I don't know, you have a plan next, I guess, for doing this. It would be interesting to give us an idea how you're going to go on.
Yeah, thank you for your comment. It was really, really relevant to what we're doing. So I know that it seems like more connectionless, But you're right that the part of data literacy is more connected to the design part. Of course, in the beginning, they just play, they interact with the objects, and they don't know that they can modify them. So that's an important aspect, that they play with that. They conceive that, that's the correct, the box turns green, so this must be correct. So the first part is more of the engagement with students. That's why we added these features. It's not specifically connected with the data literacy part. And then in the second level, we move deeper in the design mode, where they see what is going on and everything gets negotiable and changeable. So that's the idea. But of course, I know that it's a disconnection between these two, and I'm working to see how this will continue. Yes.
Thank you. I will try to continue with the question of Nikos. I can see it is a first step for data literacy, but it's important for example, for the students to the next step to test the performance of the classification, the accuracy, to find the confusion matrix, for example, to see how many students succeeded in putting the right objects in the right baskets. So we're trying to think about the accuracy of classification to see a matrix, a confusion matrix that usually used in the data science. And then they can put attributes to objects and make the system automatically find a way to put the right object to the right box, and thinking about decision trees and all of the machine learning techniques. I mean, it's something that can extend and see and go to the data literacy.
Exactly. This is okay. Sorry. This is something that we were discussing with Marianthi, how we can do that more related to that aspect and automate some processes. So it's really interesting that you propose that, and thank you for that. But we currently are not sure how we should do that. So we are open for ideas. So thank you so much for that.